in two major ways. We have the classical methods and then we have the instrumental methods. Now, the classical method is also known as the traditional method or the wet chemistry method. The classical method is also a method. Is also called non-instrumental method. All right. So the classical method is further divided into two or subdivided into two. We have the trimetric method and the gravimetric method. All right. So with the trimetric method, that's using titration. Trimetric method will involve the measurement of volume, while the gravimetric method will involve the measurement of mass. All right. So a good example of analysis done with trimetric method is, let's say, determination of protein in milk using formol method or formaldehyde method. All right. So this is a good example of trimetric method, which is categorized under classical method. All right, so classical method are, um, you know, methods that does not involve the use of an instrument. And so when you look at trimetric method, the only thing it involves is from glassware, pipettes, burettes, volumetric flasks, okay, conical flasks, and all of that. All right, and so they involve chemical reactions, and that is why they are known as wet chemistry method or wet chemical method. All right, so that is classical method, and considering the nature of classical method, you will agree with me that, of course, it has some disadvantages over instrumental method, and of course, it has its own advantages. But then, before we talk about the advantages and disadvantages of both, let's talk about instrumental method. So, instrumental method basically are methods that involve the use of instruments. All right. So analytical methods that involve the use of an instrument are what we call instrumental methods. All right. And this method, because they engage the use of instruments, this method are more sensitive. They have higher sensitivity. They are more accurate compared to the classical method. All right. So this takes us to the advantage of instrumental method over classical method. So instrumental methods are more sensitive, they are more accurate, and of course they are more faster. Yes, when you use an instrument to analyze a food sample, um, it's faster than using chemical method. And so instrumental method, they are faster, they are accurate, they are more sensitive, all right, and they minimize error. All right, so in classical methods, you human error alone is something. We cannot be perfect in our measurement of volume the way we have machines do it for us. So using instrumental method equally reduces or minimizes error. So those are the advantages of instrumental methods over classical method. And now classical method, advantages of classical methods over instrumental method would be that, of course, classical method is cheaper. Okay, classical method is cheaper in the sense that you don't have to buy the equipment, right? You don't have to buy expensive equipment. All you need are your glasswares, your reagents, your volumetric flasks, and all of that, and then you can carry out your classical method or your chemical method of analysis. So classical methods are cheaper. Another advantage is the fact that classical methods does not require skilled personnel, unlike instrumental methods that you need to have a trained personnel, someone who is an expert, to be able to operate the equipment or the instrument. In the case of an instrumental method, um, you may not need to get a skilled or an expert in that regard. All right, and so of course, classical methods are also easy to use, and they have low maintenance compared to instrumental methods. And so these are the advantages of classical methods over instrumental methods. Now, um, we're going to be talking about selecting an appropriate instrumental technique. So now our focus for this course is actually instrumental methods. All right. As a means of background, that was why we just bring that brief about classical methods. So food analysis are divided into two: classical and instrumental. But we're not going to classical now. We're talking about instrumental now. And so you want to select an appropriate instrumental technique for your analysis. So what are the factors you need to consider? All right. So I have 5 factors here that you could consider in selecting an appropriate instrumental technique. All right. The first one is precision. We have accuracy. We have simplicity, reproducibility, and specificity. All right. So these factors are very important, um, and they should shape your choice of selecting an instrument or an equipment for your analysis. And so what do they mean? So precision. Precision is a measure of the ability of an instrument to be able to reproduce a result by a specific analyst or group of analysts using the same equipment and experimental approach, keeping other conditions unchanged. All right, so precision is just the ability of an instrument or an equipment to be able to give um, the same results under the same results under the same condition. All right. So a good example of that is when you have a weighing balance, and then you you weigh a particular sample, and then it gives you the weight of the sample to be, let's say 10.5, and then you take the weight of the sample after a while, the same sample, all right, at the same experimental condition, and then we expect that the weighing balance should give you the same result, which is 10.5. All right. So when the instrument is able to reproduce this consistent results over time under the same condition, then we want to say that the instrument is precise. All right. So we have some instruments that they give you different results under the same condition. So the degree of the precision of those instruments is will be said to be very low. All right. So a good instrument should be able to reproduce results, all right, that is reproduce results under the same condition, reproduce the same results under the same condition. I hope that is clear. So that is precision. Now talking about accuracy. Accuracy is a measure of how close accuracy is a measure of how close one can measure the value to the true value of the parameter being measured. All right, so what this is saying is um, when you have a true value is um, the outcome of what you're expecting to be the outcome. For example, we have what we call standard weight. I think that will make the explanation more clear. We have what we call standard weight, and let's say you have a standard weight of 200 grams, all right, and then you put that standard weight. Now, that standard weight of 200 grams, the true value of that weight is 200 grams, all right. It has been standardized. We know that this is the expected result. Now, you take the weight of that standard weight, and then it gives you, let's say, something like 199.9. All right, so that is very close. That is very, very close to the true value, all right, which is 200. So that particular equipment or instrument can be is said to have high accuracy. All right. So, but when you take the weight of that standard weight and it's giving you something around 195 or 190 or 190 or thereabouts. All right. So that that instrument might be said to have low degree of accuracy. All right, so I'm going to use what we call a dart game to explain better what it what we mean, the difference between precision and accuracy. And I'm sure we all know what a dart game is. All right, so if you look at this diagram, and then um, and you take a look at the black dots. Now, looking at this diagram, the inner circle, the inner red circle, is what is referred to as the true value, all right, in this case. So whenever you throw your arrow and it falls right into this inner circle, all right, so it means that you you have it means you have the true value. All right, so like in the first diagram, let's take a look at the last diagram here. All right, the last diagram is actually high in precision and is high in accuracy. Why is that? Now, we said an instrument is is accurate when the value it gives, all right, is very close to the true value. So if I throw 1, 2, 3, 4, 5, 6, 7 arrows on this board, all right, and all the 7 arrows drops in between this true value, then that instrument is what is accurate, like we have it in image 4, 1, 2, 3, 4, right, where we have all the instruments falling together, meeting together inside the inner circle. So it means that the instruments will be accurate and also be precise in this case. Why? Because all of our experiments falls inside the true value, and then that's accuracy. And then talking about precision, precision is the ability of an instrument to repeat the same results over time under the same condition. All right, so when we throw this and then it also meet at a point, then that's precision, right? So an example is when you look at the second image here, all right, the second image, you'll notice that in the second image, none of the target falls within the true value, all right, and this image demonstrates low accuracy but high precision. High precision because all of the 6 arrows thrown falls within one side. All right, so it continues to repeat the same results at different experimentation. All right, so it is precise but not accurate because none of the arrows falls within the true value. So this is low accuracy and what, high precision. All right, in the case of 1, 2, 3 arrow image 3, it is high accuracy and low precision. All right. Yes, most of the values or the arrows does not fall directly inside the true value, but they are close to the true value. All right. So it still tells us that the instrument is accurate. It falls, it's close to the true value, but they are kind of scattered. So it's close to the true value, but is not precise. So this is an example of an instrument that is high in accuracy, but what? But low in precision. And the first image, the instrument is neither high in accuracy or high in precision. um, Only one fell within the true value and all other results are just scattered. So low accuracy and low precision. So I think this should give a better understanding of what accuracy is and what is precision. All right, so going back to our factors here, we have simplicity. And so this is just the measure of the ease at which um, relatively unskilled workers may be able to operate or carry out analysis. All right, so if an equipment is too difficult to operate, you don't want to get such an equipment, right? So the more this the easier the operation of an equipment, the better the operation will actually be. So you want to go for an instrument that is not very complex and it is easy to operate. And then we talking about reproducibility, which is a measure of the ability of the instrument to reproduce results using the same experimental approach, all right, in the same as well as different laboratories using the same and different equipment. All right, so what this just means is when we have two equipment with the same model, all right, they have the same model number, the same everything, but they are two equipment located in two different locations. All right, perhaps let's say one is in chemistry laboratory and the other one's in physics laboratory. All right, so if we run an analysis with the equipment in chemistry laboratory and we get our result is X, for example, and so if we run the same sample with the equipment in physics laboratory, we should be able to get X results. All right. So that's reproducibility. And if we're getting different results, it means that the degree of reproducibility of that equipment is very low, and then you don't want to go for such an equipment. Now the specificity. Now specificity is a measure of the ability of an instrument to be able to detect and quantify specific components within a food matrix, even in the presence of other similar components. All right, so um, the ability of an instrument or an equipment to be able to analyze the analyte of interest. All right, so we're interested in analyzing, okay, let me use something common. We're interested in analyzing protein, all right, in yam, for example. And we know that yam is majorly carbohydrate. All right, so some equipment might not be able to detect that protein because it is being complexed by carbohydrate or starch. But the ability of that equipment to still be able to determine protein, all right, is what we refer to as specificity, all right, or the ability of the instrument to be able to determine or analyze the compound of interest, even if those compound of interest is very similar to some other compounds. All right, so this is what we refer to as specificity. And so these are the factors that you need to consider when choosing um, an analytical instrument. And then lastly, we're just going to talk about um, instrumental techniques that are available in food analysis. All right, and this is our major focus in this course. Analysis of food products for the majority of the parameters can be undertaken using different instrumental techniques. Number one is spectroscopic techniques, chromatographic techniques, hyphenated techniques, and thermal methods of analysis. And these are what we're going to be discussing in this course. We're going to be talking about their working principle. We're going to be talking about their operational procedure. We're going to be talking about the instruments that works in each of these principles. So spectroscopy, for example, we'll talk about the principle behind spectroscopy techniques. We will talk about the instruments that run under the principle of spectroscopy, and then we're going to talk about the working principle or the operational principle of some of these equipments. All right, the same thing with chromatography, the same thing with affinated techniques, and the same thing with thermal methods. And um, so in our next class, we're going to start with spectroscopy. I'm sure you will be all ready to follow along. Thank you and have a great day.